Greetings and welcome, internet friends, math fans of all ages. We're talking today about the Isosceles and the Equilateral triangles. And these are types of triangles that will actually, we've defined these before, but we'll still redefine them today, that will discover some interesting properties about. There won't be a formal proof per se, but I'm going to give you some theorems that are true. You'll have to watch another video to know why. So here we go, some vocabulario. An isosceles triangle is a triangle that has two congruent sides. Which, if you ever go to KFC, I recommend getting two congruent sides. Them mashed potatoes, friends. Or those biscuits. Equilateral triangles have three congruent sides. I could say all sides are congruent, but that's never going to be more than three. Three congruent sides. Yeah. You guys know those tricks. And some terminology for when we are in the world of isosceles triangles. I'm going to label some angles for us. I'll label this green. Well, actually, you know what? Let's go with this. I'm going to label these two sides. The two congruent sides are actually called legs. Yep. Good old legs. And we also will have these angles. They're going to be called base angles. Yeah. Yep. And this angle up here is actually called the vertex angle. Lots of terminology. We'll be using base angles a lot. I might say legs sometimes. And these are called base angles because this little bottom of the triangle, what do you think we call that? Base. Insert all about that base music right now. Thank you. Just some side notes to my editor, which I assume. So here we go. So there we go. Yeah. Also, all of my Waddy Math content, feel free to use it as ringtones on Nokia phones from 1998. Free use. Won't even sell it. So here we go. So there's some terminology, and with that terminology, it turns out the following. The base angles theorem, which we will refer to as BAT. That's right. BAT. Which says this. Man, that was a good thing I had a pop screen. If two sides of a triangle are congruent, as shown, then the angles opposite them are congruent. The angles opposite them are the base angle. Not mistaken. Right, so notice that these angles opposite the legs, right there and right there, those angles are going to be the congruentest angles. So, yeah. So that's the good old base angles theorem. You could draw yourself a little triangle if you don't have it. Or not. Matter. But the base angles theorem, let's put this to work. Here's question 1. Looks like a 7 right there. You know, that Lisa Davenport got the best of me with that font right there. Don't know why. Shout out. Yeah, that's weird right there. I don't know what number you learned there. It's like a 7 or a 9. Well, which two angles in this triangle are the base angles? The top two. Yes. So these two angles are the base angles. So those base angles are congruent by the base angles theorem. And then their measures are equal by def of Kong. And then by substitution, I could write an equation like the following. 8x minus 7 is going to equal the 7x plus 2. And that's true by the base angles theorem. And my algebra buddies are now stepping in. Tag team your algebra past self. Let's subtract 7x from both sides. 8x minus 7x is just x. In order to fit the work, we can't really write our work steps. We're just going to have to write each line. Sorry about that. Man, she got the best of me there, too. Didn't give us enough space for these foldable notes. So subtract 7x from both sides. It looks like just 2. And then how do I solve for x there, friends? How do I get rid of that? Add 7 to both sides. So x equals 9. So now I've got to find the y. And I could, well, a couple options here. They didn't actually ask me to find the measure of these purple angles, but I think it will actually make things a little bit easier. Let's plug this in up here and figure out the measure of one of those purple angles. 7 times 9 plus 2. 7 times 9 is still a mystery of the universe. No one actually knows. I don't know. And that adds all together to be 65. So that means this is 65 and this is 65. Because those base angles are congruent. But how am I going to find y? Now, it looks like these are 3 angles in a triangle, friend. Those angles add up to hundo. So I'm going to say the following. 2y plus 65 plus 65 equals hundo 8. Y'all liking it? Y'all liking it? All right. Combine those 65s. That's like hundo 30. 2y plus 130 equals 180. Subtract that 130 from both sides. I get 50. And div 2. Y is 25. So I'm going to have my real life friends give question 2 an attempt. And internet friends, in the meantime, you can hum a song in your own head for like the next 50 minutes. Enjoy. Or you could scrub forward until you see my mouse start. I was going to say my cursor start moving, but I don't curse on this channel. All right, let's... Hi, internet friends. I'm back. Didn't mean to break the fourth wall on there. Really confuse you when I do that, though. That's that. Oh, now it's all off Zoom. That's gonna be bothersome. Even. All right. So, base angles theorem. The base angles are opposite of the congruent legs. So that's going to be this angle right here and this angle right here. So by the base angles theorem, I could say that the 4x minus 22 is equal to the x plus 4 by the bat. I could have said the other way around, but I preferred putting the larger positive variable coefficient on the left, so that way my x's land on the left side. Doesn't matter none. So to solve for x, I gotta get those x's together. Subtract 2x from both sides. 2x minus the 22 is equal to 4. And how do I get the x by itself? Yeah, I'll add 22 to both sides. That's equal to 26. Div 2, div 2. X is 13. And similarly to that last problem, I'm going to find this angle measure first. So I'm going to just do times the 18 plus 4. So that's 26 plus 4. That's 30. So that angle's 30 degrees, right? Both of them. Both of them. How am I going to find y? Y. Yeah, I'm going to try some here. Hundo ate. So I'm going to say 4y plus 30 plus 30, or times 30, however you want to phrase that, is equal to the hundo at. These, by the way, are true by the trisum theorem. And add those 30s together is 60. Are you guys digging this? Working for us? Subtract 60 from both sides. 4y is equal to 120. And div 4, div 4. I think that's 30. I like it. I like it. Well, if you want some more of this, let's scroll on down, or for you in the physical world, we'll flip to the next page, maybe. Oh. Yeah, I could use my face in the corner of my videos, huh? What? Wait a minute. The base angles theorem is true in reverse? All right, so the converse means you swap the hypothesis and the conclusion of an if-then statement. The base angles theorem said if it is isosceles, then the base angles are congruent. Converse is going to be if two angles, right, base angles are congruent in a triangle, then the sides opposite them are congruent. So notice here I'm starting with my angles, and I'm going opposite those angles to conclude that these legs are congruent. That's the converse of the base angles theorem. We're going to call that, you know what? The CBAT. Yeah, CBAT. So let's use the CBAT here together. I think we could speed run these problems pretty quick. So these angles are congruent, therefore the legs opposite them are congruent. And I could say 5x plus 7 equals 42. And actually, even if all you write was that, right, your future self already knows algebra. You don't need to, write all the algebra steps out if you don't want. It's really the geometry is the thing I'm teaching you today. Subtract 7 both sides, 35. Man, that would be embarrassing. I'm like, you guys all know algebra, and then I proceed to mess up on my algebra over and over and over again. Oh, and now I've added pressure to myself. X is equal to 7 when I div both sides by 7. And that's true by the CBAT, converse of the base angles theorem. Similarly here, these angles are congruent, so the sides opposite are congruent. And actually, I don't even need this 20 meters. So I'm going to call this 12x plus 3 is equal to 8x plus the 19. Why is that true? How do I know it's true? CBAT. CBAT. Subtract the 8x from both sides. I think I'd have 4 x's left. Equals 19. Wait a minute. It's gonna be ugly. Oh, minus 3. Oh, good save. I was like, I'm gonna add 3 to both sides, and then that's not that, like, obviously things can be decimal. fractions. Those things exist. Sorry, Pythagoras. Right? These irrational numbers could exist, although that actually wouldn't be rational. That Pythag would have been a fan of the answer. Div by 4 both sides, I get x equals 4. So that's the corollary, the converse of the base angles theorem. So both of those theorems apply when you have isosceles triangles, or, well, this one becomes an isosceles triangle because the two angles. Yeah. All right. Well, guess what, friends? They ain't the only theorems we're learning today. We're also learning the corollary to the base angles theorem. Oh my goodness. Hey, check this out. Isn't like an equilateral triangle like also just a whole bunch isosceles, but then another side is congruent? It's like that. So watch this. Here's the logic. Imagine the corollary to the base angles theorem using the base angles theorem. If I looked at just these yellow sides being congruent, I could have said that these two angles are congruent. And then I could have said, well, wait a minute. Not only are those two sides congruent, but these two sides are congruent. And then I could have said, oh, the angles opposite them are congruent. And then I'd be like, wait a minute, the yellow angles are congruent. The orange angles are congruent. I think by transitivity, all of those angles go berserk. That was a Hippos Go Berserk reference. All the hippos go berserk because all through the hippo night, hippos play with great delight. But at the hippo break of day, hippos all must go away. It's a children's book. Yep. I've got the chillins. So all the hippos go berserk. All the angles are congruent. That we're gonna call the Corbat. Corbat. All right. Corollary of the base angles theorem happens to work. Man, that sketch is crazy looking. So, oh, this question is good. So if these all three are the congruent, so it's an equilateral triangle, that means by the Corbat that all of the angles are congruent. Question. I could say 5x plus 25 equals 4y, and that's also equal to 32z minus 4. But that would be a single equation with 3 variables, which is unsolvable, at least down to a particular answer. So there's got to be some other fact that I'm missing. Now, question, friends. Those green angles. Does anyone know what those green angles must mean? All 3 of them are 180, and if all 3 of them are congruent, I could just do hundo ate divided by 3. They're all 60-degree angles, friends. Yeah, you like that move? And now I can just set a whole bunch of these angles all equal to 60. All right, so I'm just going to say, let's solve this. 5x plus 25 equals 60. So 5x equals 35. Hey, I solved that before. This. Lazy Mr. Quaddy. I can screenshot the wrong color, but my laziness actually took longer than it needed to come out as good. That. There you go. Then I could solve for y by saying 4y equals 60. Div 4, that's 15, friends. I'm not going to put it right the degree. And lastly, I want to find that z. Guess what? 32z minus 4 is equal to what? Careful writing a 2 next to a z sometimes. Ugh. Plus 4. So 64, and oh, doesn't that divide nicely? Look at, I'm going to write a capital 2 for this answer, as opposed to these lowercase 2 right here. Capital 2. Or maybe it's a cursive 2. It's one of them. One of them for sure. So z is equal to 2. Yeah. So that's the corollary of the base angles theorem. If a triangle is equilateral, as in all three angles are congruent, then it's also equiangular. And guys, guess what? The converse of that is also true. That's right. Our last theorem of the day is the corollary to the converse of the base angles theorem. Oh boy. So here we go. If I've got all the three angles congruent, then the sides, the sides, those are also congruent. And what's a good name for this one, friends? Maybe the core CBAT? Man, we've got a lot of crazy names today. That's a little weird. All right, how's that going to help us out on question 6, though? Okay, they're all 60 degrees. And I could say that, it's also equilateral. Here, I'm going to actually trip that hashtag right there. Boom, look at that. Because those, when you do the little triple marks for congruence, they look like whiskers sometimes. Oh, it's nice. And so using the core CBAT, I know that all of these are congruent. And then by like def of Kong, their measures are equal. And then by substitution, these two things are equal to each other. So let's, guys, did I only solve for X on a previous problem? No. Okay. All right. I just realized this question was asking for more than that. Thoughts, questions? Sure. So, man, I almost so didn't solve this the whole way. That would have been embarrassing if I did this whole video and then at the end I never found the perimeter. Wow. Subtract 6x from both sides. That's 3x minus 11 equals the 16. What do I do? What do I do, friends? Let's add that, Onse. That's like a 27. And div 3. New wave A. Now, that's the value of x, but let's find this perimeter. I'm going to make that a light blue. So if x is 9, what do I do? What do I do? Yeah, let's throw that 9 into one of these x's. I'll throw it into this one. So 6 times the 9 plus the 16. Oh dear, that's like 54 or something plus the... No. Wait a minute. Yeah, okay. All right. You know what happened? I thought I was solving for angles, and I was like, these angles need to be all 60. Why am I not getting 60? But that's not the case. 54 plus the 1, 6 is the 64 plus the 6. That's 70. All right, and so that's like 70 centimeters, technically. So if I want to find the perimeter now, it's 70, 70, 70. And so the perimeter, P is equal to, I could just call that 3 times 70. What's that going to be? 210 centimeters. That's the race number of my good friend of anonymous name fame. And shout out to the racing of that. I assume you race motocross. He takes that dirt bike by the hand. Yeah. Also, maybe he races John Deere. No one knows. All right. Well, thanks for watching, internet friends. Tienen un día el más bien del mundo. Adios.